Yeah, it's now. It's already. It's live now.
Okay. Good afternoon to all. Respected Soma sir, Tyagi sir,
Tyagi sir is calling me back. Just 1 minute.
Soma madam. So, welcome to the 14th lecture of the lecture series on radar meteorology, jointly organized by South Asian Meteorological Association and Advanced Center for Atmospheric Radar Research within University of Science and Technology. So, without much introduction of the speaker, we had a very elaborate session last week from Dr. Soma San Roy madam. So, today's talk will be in continuation of the previous talk, application of DWR products for nowcasting. So, without much delay, I request Professor Someshwar sir to make the welcome address.
Thank you very much, Dr. Avilas. Today's distinguished speaker, Dr. Soma Roy, and our colleagues, Dr. Avilas, Dr. Swagata, Rakesh. Afternoon and welcome to the 14th lecture of the series on Meteorology, Soma and ACARR, the Advanced Center for Atmospheric Radar Research at Cochin University of Science and Technology. Today, Dr. Tyagi Saab, our president of Soma, will not be able to join probably because he is in a function. He just informed me. So we have started the lecture anyway. We would like to thank so much to Dr. Soma Sanada because I know, and last week we have talked about it. She's in Pune at present, and already she has to deliver lectures at IMD probably to the trainees. So somehow she found time to deliver lecture for the radar meteorology suite, and also she had said that there are some network issues of the internet. So bear with us in case if her network fluctuates. Regarding the background of the lecture, already all the participants know the background, and the speaker is also not new because this is our second lecture. It's a very interesting topic, as you already know. She had given the first part of the lecture on last Saturday, the nowcasting of weather using Doppler weather radar. And I remember that a lot of interest was generated. The last lecture, a lot of varieties of questions were raised. So I know that in today's lecture also, you'll find a lot of interesting things and a lot of curiosity to know. So please write down your questions in the question and answer box, and the speaker will answer your question at the end. So thank you very much once again. Enjoy the lecture, and over, Dr. Avilas, please.
Thank you, sir. Now, without introduction, because already we introduced the speaker on the last week, and directly we are moving to the today's lecture. Thank you, Somas and madam, for joining with us besides your busy schedule. Because last week also, when I called you, you were busy with the cyclone forecast, and yeah, we know that you are a busy person. Otherwise, thank you for joining.
Please don't embarrass me by saying so many times. Yes.
Yeah. So please
Shall I
invite you
start?
to. Yeah, please.
Okay. Is my slide visible?
Not yet.
I'm sharing the screen.
How to share it? The screen.
Please grant browser access to.
Okay.
Okay.
Yeah, ma'am should be co-host.
Yes, I am co-host, but let me try to share. Is my screen sharing now?
No, ma'am.
Actually, I'm doing it from my own laptop, so that may have some problem. Let me try again. Window. I'm the host. Let me try to share. Sorry, just 1 minute.
No problem. But it's a Windows system or Mac?
It's a Mac.
Hmm.
Web browser privacy permissions. Better meeting experience.
Maybe it's a
Browser settings. This is the problem with any device's system preferences. System preferences. Where do I get system preferences?
If the problem persists, then you can send your PPT to one of us and we'll share
I
this.
think that will be better.
So quickly send the PPT to one of us and we'll share the screen and then
Who can I share it with, please? Who can I send it?
Madam, please share to that ACARR email ID, ACARR@CUSAT, in which
ACARR.
@CUSAT.ac.in.
Dot IC.
AC.in,
AC,
ma'am.
AC dot.
ACARR.CUSAT.ACARR.in. Is that okay?
ACARR. I am writing in the chat box.
Okay.
It came. ACARR@CUSAT.
Yes. Okay. I'm just sharing it, huh?
Rakesh, അവിടെ നിന്ന് share ചെയ്യാം.
Just 1 minute.
Rakesh, your attendance should be ready.
It's ready, sir. It is ready.
Okay.
Yes, I've sent it. Can you please see?
Yeah. Rakesh, അവിടെ നിന്ന് നോക്കാം. തീർന്നു.
I don't know why it is not sharing.
because of the Mac, you are in the working with the Mac, right?
Got it, madam. Got it.
Got it. Thank you. Can you
Will share.
go? Yes. Can you go directly to slide
അവിടെ നിന്ന് open ചെയ്യണം.
28? Slide 28.
Screen ഉണ്ട്.
Yes. Thank you. Yes. Can you make it in presentation mode, please? Apologies, Dr. Abhilash.
No issues.
I'm putting you into trouble. Okay,
No.
thank you. Thank you for your cooperation, everybody, and apologies for this mistake. But somehow I've noticed Mac gives some problems in this kind of VCs when you try to share the screen. Can we start from here today? Uh, just to give you a brief background of what we had talked about. Can you make it a full thing? It seems like two screens are coming for the same. Yeah, in the right hand side also, yeah, right hand side also something is coming.
Yeah,
Yes,
yeah.
this is better. This is okay. So, last time I had talked to you about the use of radar data. The initial part of our this talk was, I mean, the first part of this presentation was focused on the direct use of radar data in observation in operational weather forecasting. Uh, Please understand that radar data is one of the, in our SOP, if you remember, we had discussed that in our standard operating procedure by which all forecasts take place. The final step of the forecast is to analyze the radar data. So the entire forecast process involving use of climatology, global models, the various physical and thermodynamical and dynamical parameters, after analyzing everything and then coming to the nowcast scale using satellite, lightning, every other data source, we finally move to radar data. But that is not the only place where radar data finds use in the operational setup of IMD. Uh, if in this case, like the extrapolation and persistence, that is the main ways, these are the main ways in which we use the radar data in the final stage. But the use of radar data starts much earlier. Can you go to the next slide, please? So if you see the, can you just press the next button? Next screen, if possible. Yes. So when we are seeing the use of radar data, while of course in the final stages, that means just before giving the nowcast, we need to consult the actual radar data, but radar data is entering the process much earlier. Uh, I would say from the short range scale to the nowcast scale, radar data is entering the forecast methodology through numerical weather prediction models. Mainly the mesoscale models, radar data assimilation is an important component of the improvement of the mesoscale models, and that has now become a operational requirement and an operationally available product for smoothly giving the forecast in future. Uh, can you go to the next slide, please? So, why do we need model based nowcasting? Two things are here. First is every process has a limitation. When you're talking of observation based forecasting, like I talked to you about, uh, an observer's limitations come into the picture. Until an observer gains experience enough to be able to give a clear cut guidance, oftentimes forecasts go very wrong. uh, when if the forecaster is firstly new to the job, secondly not fully conversant with the requirements of the job, and is for some reason inattentive. For all these reasons, the manual qualitative nowcasts need to be supplemented by the automatic nowcasts that are available. Of course, the last stage forecast is, of course, the domain of the operational nowcaster, but before that, he or she requires this support in order to give an informed output to the general public. Next, please. In IMD, what do we have? In IMD, we have three models where radar data is being used. The SWIRS is one model in which radar data is being used in for it is a nowcast model. So this is some difference that we shall talk about. The HRRR, the high resolution rapid refresh version of the model, WRF model, that version also incorporates radar data on top of the other data sources that are there. EWRF I've mentioned here, but it mainly uses lightning data. The fourth model, which is not mentioned here, is the NCOM-R, which is produced by NCMR WF. These four models form the main backbone of the short range weather prediction of IMD. Next, please. So this is not automation of the nowcasting is not a new process, and in fact, in some countries like US, Canada, Australia, they have made it an operational fact. This automatic nowcasting, we use automatic nowcasts for as an input for the manual nowcaster to give a forecast. So our process is a bit different, but our work on automatic nowcasting started after a USAID project trained many of our forecasters and from India from 2010. Next, please. So most of these nowcast softwares, if we talk about, there are, firstly, we need to distinguish between nowcast software and a numerical weather prediction model. See, basically, when you talk of a numerical weather prediction model, the benefit of the model is that the model ingests the data through primitive equations, through various the modified hydrostatic equation, as you may be knowing, and then it extrapolates the data using the primitive equations of which are the basic fundamentals of fluid mechanics and of dynamic meteorology that we study in the beginning. So that is the kind of work that is done by a numerical weather prediction model. But what happens is that this process, this ingestion of data, assimilation, and then providing a forecast, this entire process takes some time. Tropical weather often changes very much. There is a very rapid change in the atmospheric structure within a very short interval. Maybe a thunderstorm's lifetime is only for half an hour. So by the time the data has the current occurring data is ingested, and the model has assimilated, has given a prediction. And again, for a model to the initial half an hour or so, initial period, I will not say half an hour, depending upon the scale of the model, whether it's a global model or a mesoscale model, tends to have the spin up errors, because of which the model output is not very well usable. So what is the how to bypass this problem? So if you the nowcast softwares are used to bridge between the current observation, and uh, the numerical models which are available. A brief thing about nowcast softwares, because now every time we buy a radar, the various radar companies, the vendors, they come up with that you use this and versus that. There was a very uh, if you separate out nowcast softwares, there are four main categories of softwares. I mean, globally, these are globally four kinds. So, first of all, nowcast softwares are not numerical models. Please understand this very clearly. Nowcast softwares function on a mode of bridging between observation and the output of numerical models, but they have a very important purpose. Like I told you, this bridging time is required. We cannot wait indefinitely, and oftentimes the requirement is very immediate and specific. For that, nowcast softwares play a big role. The first category of nowcast softwares are cell trackers. Cell trackers, they function on a very simple principle of they track individual thunderstorm cells, their development, their decay, their movement. Now, individual cells do not always move or propagate at the same speed or in the same direction as the general area. Individual cells form along a gust front, and they're tall cells, and so the propagation is not the same as the propagation of the entire convection area. This is something you must remember. So But at the same time, thunderstorm cells are the locations where the maximum weather happens, the dangerous weather, in terms of hail, squall, lightning. So, cell trackers, in theory, are the most fine resolution nowcasting tool available for us. You see a cell currently, you see its evolution, and then extrapolate this thing to the next stage. Uh, the problem is this: for India, cell trackers, our thunderstorm cells, especially if you see our pre-monsoon cells, are maximum 10 to 20-minute lifetime. Maximum. Sometimes they're 10 to 15-minute lifetime cells, which means that a cell tracker cannot track a cell. And we have a scan strategy because of our radar limitations. We have a 10-minute scan strategy, so the radar cannot give a higher resolution uh, structure of the cell. The other problem is the communication aspect. What are we going to communicate? Who are we going to communicate it to? If this forecast is to go down the line to a person to react, that also should take time. So one is our cell lifetime is small. Second is the whole methodology for communication, for generation of the forecast, observation, generation of the forecast, communication. All this is likely to take a long time to for before and much before that the cell will have died down. Then what is the method ahead? The method ahead is the area tracker. Now, area trackers, I'll show a little more in detail what are area trackers. Uh, these basically predict, I'll give you an example as to how the area trackers work and what is SWIRS exactly. We have worked with two of the area tracker softwares. One is SWIRS, the other is WDSS2, a warning decision support system. One is from Hong Kong Observatory, the other was from National Severe Storms Laboratory. They track an entire area rather than a single cell. The benefit of this is, yes, it will be less accurate than cell tracker, but the benefit is the area of thunderstorm occurrence or the area of convection is much larger than that of individual cells. So, and if you are able to predict the movement of such an area, evolution of such an area, maybe that individual cell will not be tracked, but the area and the overall structure of the area can be predicted much better if we are using a area tracker kind of software. The third method that I said is basically Nowcast softwares function as a bridging software between current observation, and the model forecast. So initially, the area trackers are sometimes after the first few cycles or first few first maybe if it's a 2-3 hour area tracker software, then the first hour will be mainly based on the area tracking. Gradually it will blend in with the model products. So model products are less accurate, but they have a long they're more accurate than say the extrapolation based area trackers. So that is the third kind of softwares we're talking of. We have worked a little bit with UKPP and steps, but again, area trackers are they have a better way of they basically attempt to merge the observations with the NWP forecast. So all the three are linked together. The final is an expert system, Auto Nowcast or Nimrod. These are two softwares which are expert systems. Uh, I'll talk very briefly about this, and I'll also discuss why these softwares are not very popular, the expert systems. Oftentimes, the highest level does not really work in most setups. Can we go to the next slide, please? So this is the principle of all extrapolation based, all nowcasting softwares, at least the first two, the cell tracker and the area tracker. Uh, the principle is very simple. It detects either a thunderstorm cell or a thunderstorm area over 2 or 3 cycles, builds up its based on either a neural network training network behind the thing or some other tools that are available. Many other tools are also available, and basically forecasts ahead in time. This is important because this gives the then the evolution and the movement can continue as per the previous trends that are available. Naturally, if you remember the first slide today that I showed you, the extrapolation based software, first half an hour, first 1 hour, forecast is very good. Beyond that, forecast starts to deteriorate. And that too, when I say 1 hour, it depends on the season, on the type of weather systems you're monitoring. If it's a monsoon system, up to 2 to 3 hours, forecast is not at all bad. If it is a pre monsoon system, forecast accuracy tends to decrease quite quickly. Next, please. So this is the Swirl software, the one that we have received from Hong Kong Met Office. It was implemented first during the Commonwealth Games, and more recently the community Swirls is available in IMD since 2018. It is operationally being run for one or two of the. It is for individual radar scales that are happening. The Swirl software basically extrapolates radar echoes based on according to speed, direction of movement, and whether they're merging or separating. So that that is a uh, the methodology. I'll show you a couple of products in which you can see that the forecast again. When we are talking of any of these nowcast models, these nowcast models are have been developed over a particular area, and oftentimes the while performing very well in the mother area, when you try to implement, unlike NWP models which solve primitive equations and try to give a standard uniform kind of forecast accuracy, nowcast models tend to perform best in the area in which they have been developed. But we are using it in Delhi, and we are receiving, especially for monsoon systems, very good results, but not so good for other seasons. Can you go to the next one, please? The This is the swirls output. For example, this is the if you see the left hand side picture, the 30-minute forecast and the corresponding observation, that means now 1522 hour forecast valid for 1552, and what is the actual observation of 1552 is shown in the right hand panel. So as you can see that it is giving, if a person wants to use this as a tool for any other purposes, and here there is this has a lot of use, especially for when you are trying to build a chain down the line. For example, if you are to give a hydrology forecast, if you are to give a water level rise, and whether there is a likelihood of this kind of rainfall, where will the zone shift, and accordingly whether there is certain catchment coming into the becoming more vulnerable. So all that, this kind of a tool becomes a very good use of much use. That means from the forecast, from the observation to the forecast, 30 minutes, it is in the month of May. So the forecast was quite accurate in the 30-minute scale. But when you go to the 60-minute, can you come to the next one, please? So when you go to the 60-minute, you can see that in the observation to the top left corner, there were around Patiala and this region, Jind, Patiala region, Kathal. This region, there were a lot more thunderstorm cells that did not that were not there about an hour back. Hence the model could not give any prediction. So a major failing of this particular model has been the inability to catch the initiation and the and this is true for all Nowcast models because they will extrapolate based on current observations. So they could not predict the initiation or the dissipation, complete dissipation. Maybe dissipation was being caught, but initiation was not being caught. So growth, decay was being caught, but not initiation or total dissipation. Yes, next please. So 120 minutes, you can see the forecast really deteriorated. So one major thing is that if there are cells with longer lifetime, if not cell, the area has a longer lifetime, the forecast accuracy improves. But coming closer, its forecast accuracy decreases. The best way to handle this was that this is a 10-minute updating cycle. So every 10 minutes a 3-hour forecast is given. So anytime one sees the forecast is always the error, as you can see, that it is always going to decrease over time. So the optimization of the forecast related activities can be done in this kind of a software. Next please. So the other way that in which the numerical models are the radar data is being used is through assimilation in thunderstorm forecasting. So currently there are two models in India which are using the radar data in a greater amount. The first one, can you please go to the next one? Yeah, so this I have some slides I have taken from our colleagues in the NWB division. So the first one is the HRRR, High Resolution Rapid Refresh Model. This has been installed in the Aditya Hyper Computing Systems and in January 2021, and it has now been ported to Pratyush. So these are the names of the hyper computing systems, first in IITM and then in Seva W. In both it is there. So now the HRRR model runs in three domains because there are lots of radars and 39 radars as you're aware of, and in three domains: North India, East and Northeast India, and South Peninsular India. For each of them, as you can see, it's an overlapping area, and for each of these regions individually, the model is updated every 2 hours. Can you go to the next one, please? Every 2 hours, and there is a forecast, valid forecast for 12 hours. Effective forecast is 2 hours. So every it takes around 2 hours to give the prediction, and effective validity time is only 10 hours. So overall 12 hours, of which 2 hours is taken up by the model run, etc. And this is run maybe every 2 hours, but the model is of course for all the three regions separately. What it does is it can you go next one, please? What this model does is it ingests the next slide. Next slide, I'm not able to, yeah. So what this does is basically it takes the DWR, mainly radial wind data, and it uses a 3D bar assimilation with this data into the initial guess field, in which already the other data from the synop observations, satellite, and etc. have been incorporated, and then it ingests radar data and gives the forecasts. So the forecasts are available at hourly intervals, so that this gives us a good idea about where the uh, rainfall and thunderstorm activities likely to occur. Next one, please. The other mod. So this is an example where you can see that over Bengal and Odisha, there were on 6th May, there was the model picked up very well that there would be a squall line kind of structure, but there's slight displacement. Now, this displacement is an important component of using model forecasts. But nevertheless, the idea is that this is a very important component of the standard operating procedure for nowcasting, not the forecasting, but the nowcasting scale of model forecasts. Uh, Next, please. So this is showing the radar. First was the radar, and then again the lightning. So as you can clearly see, the area has been very well picked up by the radar. It is not by the model. It is not always true, though. I'll tell you very frankly that once we this is not a forum for advertising the HRRR model. It is to actually talk about the operation requirement. So in the operational setup, we do not depend only on the HRRR. There is another model. Can you please go next? This is the model, the income R model, which which is also ingesting radar data. Now, the benefit of the we have generally found that this model also, of course, every model has its errors, but used in conjunction with the HRRR, we have been able to efficiently use this for our nowcasting. And when we are talking of when we are talking of our uh, district level, block level, village level warnings, which is now the demand from the public and from the user community and other stakeholders. There, this kind of a tool where we have the data available. Of course, you're seeing the images, but the data is available at 4 kilometer resolution. HRRR is available at 3 kilometer resolution. So, this kind of high resolution data, their availability is of extremely great use, especially when we are talking of the nowcasting. This next slide is a bit messed up. What happened exactly? Something is wrong with this. I'm sorry, this slide seems to have got mixed up. It can something is wrong with the slide or what? Sorry, just let me check if the slide in the original was okay. Oh, okay. Sorry, this slide seems to be in error even here. Can you go to the next slide, please? I'm sorry about this slide. So, radar data, if we come to it, it serves in two ways. One is our model we give the thunderstorm forecasts, weather forecasts, rainfall forecasts in two stages. One is the medium to short range scale, where we need to use mainly the NWP models, where radars radar data is not directly in use, but it is in use in the through the mesoscale models, whose daily scale products we use for the medium to short range forecast. The other way in which our radar data is being used is again in the final stage. So radar data is used twice, but again, please remember, it is not the only tool. We do have radars now, but the process of for nowcasting has started from 2018, or even earlier, from 2013. The first came, but that was mainly radar based. But from 2018, we have developed an SOP where radar data forms only one component of the entire forecast procedure, and that too observational use of radar data is a very you can say a very final stage of a forecaster's requirement. The medium to short range is mainly on the basis of various stages, whether it is global models, the global model forecasts, climatology, the global model forecasts, global factors, the finally the thermodynamic dynamic indices, and then we have a medium to short range forecast of thunderstorms. Even in the nowcast scale, the radar data forms before the radar data is used. Satellite data is the most major component, followed by lightning data, and only in the final stage the radar data is used mainly for the observation, for the final stage of monitoring. So using the data we do have, we now give nowcasts for around 16 categories of thunderstorm and associated phenomena. As you can see that these categories, partly they come from the medium range, partly from the short range, from the lightning data and the satellite data, and again partly like the severity, it comes mainly from the radar data. So all these aspects are are taken into account by any forecaster when he wants to differentiate between, especially radar data is used for differentiating, say, between whether there will be a lightning versus, we only give forecast for a lightning strikes on the ground, or squall, or ordinary thunderstorms, or hail. So that distinction comes mainly from the data of the radars. So the more radars are coming up, the forecast accuracy, we hope, will improve, and especially short term intense activity will be better captured. But the other aspect is also equally important, the communication of the warning, the creation and communication of the warnings. Without their communication in the right forum, in the right way, the forecasts, like I talked about Titan software, the Titan software becomes useless in the Indian context. Whereas swirls, even swirls is having, I mean, it has to be, it has limited efficiency because our communication channels, communication networks, not everybody has an Android mobile. Not everybody is looking at their mobile while they're working. So all these aspects need to be taken into account when we are giving a forecast and a nowcast. I think, thank you. That is all that I have from my side. Uh, any questions you have, I can take.
Ma'am, we have some questions.
Yes,
Can
please.
HRR software can be used for cloud-based events?
Can HRR software be used
Yes.
for
Can be used for cloud-based events, predicting
cloud?
the cloud.
Yes. So this is a very significant question that not only maybe a participant, but we face this question every time we have a meeting with disaster managers. See, the difference between a cloudburst and a normal event, you must understand, is the time of existence of the cloud. That is very important. If we see a single snapshot in the radar, it is very difficult from the radar to give a prediction that, okay, this is going to be a cloud burst, or this will just be a very heavy rainfall, or this will be an intense spell. The kind of mesos, so if you have to, what is a cloud burst? Cloud burst is a lot of rain in a very short time. So a lot of moisture has to come in. So only monitoring radar data is not going to give the answer. Very mesoscale observations are required in the three dimensions in order to say that yes, situation is right, that many factors have come together, situation is optimum for an intense spell of rain. Very rarely do we get that kind of observations, especially where the cloudburst events generally happen, say over the mountainous territory. As it is, we do not have such density of observations, and the local factors monitoring at that higher resolution. Hence, the cloudburst event monitoring is very difficult. It is true whether using radar or any other source. It has to be monitored through a multiple of sources with very mesoscale observations.
Ma'am, next question is about whether Nowcast software used for range prediction is only used for rainfall or can be used for thunderstorm events also.
It is the you see the it's this is also a very good question. Actually, it is dependent upon a country's requirement. I did not talk about the auto nowcast or the other things. Whatever a country faces as a problem, they focus on that. For us, thunderstorms are more important. For Hong Kong, they had greater stress on rain, so they predicted they have the tool is more tuned towards rainfall forecast. But say WDSS2 was a software which we used, which we are no longer using for various reasons, but that is the software. Now it is coming as MRMS from National Severe Storms Laboratory, that was tuned towards thunderstorm forecasting. Again, thunderstorm forecasting is a thunderstorm evolution is very fast. So when we are talking of thunderstorm, say downbursts, the signature or tornado formation or severe gusts, any kind of gusts, the timeline of evolution is very rapid. You must understand that radar is only one of the tools that comes in the picture, that to at the end stage. At that stage, to analyze, issue, take action, these three things is very difficult to use. So the stress should be more on higher resolution of observations and merging them together through through assimilation into NWP models, and also through SOPs, so that high resolution events are not missed.
Okay, ma'am. Ma'am, another participant is asking whether does this Nowcast produce warnings?
Operationally, we whatever warnings are issued, they're in India, they're not going directly from the Nowcast software. Nowcast software is one of the tools we have. I've not shown you. We have a decision support system. A decision support system puts all these softwares as layers on top of each other for a forecaster to take a decision. The final forecast is always issued by a manual forecaster sitting at a decision support system terminal. It is not automatically going to the public. No.
Okay, ma'am. Ma'am, and next Q&A is about flash flood nowcasting. What about flash flood nowcasting?
Flash flood is a water-based thing. That means your you must understand what again we are talking of rainfall accumulation. It can radar can give around it what is the rainfall, but to use this product, use data of multiple radars to and through the nowcast softwares, when we are talking of, if it is giving a prediction that this is the region where the rainfall is likely to increase, uh, to relate it to the flash flood, yes, then it needs to be modeled in. There is no such model available currently which is using this kind of nowcast tool to give a flash flood warning, for the simple reason that we do not have that linkage is missing between what is happening in terms of rainfall and what is happening in terms of rainfall accumulation. And this is again, you must remember, this is requires a lot more hydrological input. The first day of such a rain will not give you a flash flood, maybe the 10th day of such a rainfall where the rainfall is accumulated. So lot more modeling, not just the current rainfall, is necessary for giving the warning for a flash flood.
Ma'am, next is can you discuss more about NCUMR and what type of models are used for extended range forecasting?
They're two different scales
Okay,
entirely. Okay, no, no.
fine, ma'am.
Let me try. Income National Center for Medium Range Weather Forecasting. They're using the unified model of UK Met Office. Now, this unified model of Met Office has a forecast scale from seasonal scale to monthly scale to for short medium range, which is 1 to 5 days, 1 to 7 days, to nowcast scale. So in the nowcast scale, short range and the nowcast scale, not nowcast, short range scale, this model, the UK Met Office model, uses the radar data assimilation. In the larger scales, it uses the other parameters, the synop observations, the satellite observations. It uses all that data, but only in the nowcast scale or the short range scale, it uses the radar data is assimilated, and from this the forecast is generated. So that is the short range and nowcast. So every 3 hourly it gives a 48 hour 72 hour forecast with the 3 hour difference. I mean, every 3 hourly as well as daily forecast. Daily forecast we use for the medium to short range, 3 hourly forecast we use for the nowcast. That is how we are using UK Met Office short range forecast. Now when you're talking of extended range is from the same suite of models, but the methodology is different. If you solve primitive equations, the same primitive equations have a different view when you're taking in the mesoscale and when you're taking in the larger scale. So though the model suite and the physics remain similar, the global, when you're talking of extended range forecast, the forecast is, it follows down, but the point is it is not downscale. It is the model re evaluates during the medium range, and again re forecasts in the short range to nowcast scale. They are not downscaling. I hope you understand that. Yeah. Okay.
Are the softwares available in the market or provided upon purchasing the radar system? Yes.
Okay. Uh, Now let us talk about some of the softwares. Say WRF. It is open source. You can many people are many young meteorologists have started our careers with WRF model. That is, and before that there was MM5. So the US has been kind enough to keep it open source. But when we are talking of other models, suppose in the nowcast scale, say community swirls. This is again available upon request, but it is available openly. But other softwares, whether it is UKPP, whether it is MRMS, these softwares require license, and you have to purchase the license.
How can DWR applications be used to reduce the impacts of extreme weather events?
DWR is a tool for a snapshot view of the atmosphere. This is something you must remember when you're using DWR products. It is not a one-step solution to all problems. When we are talking of downbursts, when we are talking of squall, when we are talking of hail presence within the thunderstorm, I'm not talking of hail on the ground, hail presence within the thunderstorm. When we are talking of lightning, the radar is the best. Doppler weather radar is the best tool to give a prediction. Now, when you're extending this to say rainfall accumulation, whether there will be extremely heavy cloudburst kind of events, whether there will be say fog, then you are extending beyond the scope of a simple snapshot of a radar image. You need other tools to support that observation. For example, if it is a just I'm trying to put it more I'm trying to put it more clearly. Say you seeing a cloud, whether it will live for 1 hour or whether it will stay there in the same location for 6 hours. If it stays for 10 minutes, rainfall will be 2 millimeter. If it stays for 1 hour, rainfall will be 20 millimeter. If it stays for 6 hours, you might get rainfall of 200 millimeter. So, what decides? It is not if you're seeing a single snapshot or if trying to give a prediction based on a single snapshot, you're definitely not going to be able to. Nobody can. You have to see other factors. What has been the moisture increase? What is the wind like? What is there a convergence happening over this location? Is this a large scale convergence that will sustain for the next 6 hours? Then you can say that there will be an intense spell of rain. Otherwise, it is very difficult to see a single radar image and try to predict all extreme weather. to my knowledge, this is difficult.
And one final question: usage of GPS radio sound in nowcasting.
Actual GPS radio sound does not require in nowcasting. Okay, GPS radio sound is a something that gives measurements twice, once or twice a day, whenever you're setting up the balloon. But it has a very major use, especially for thunderstorm prediction. Now, two or three very important factors come out of GPS radio sound. First is the freezing level. The freezing level is a very important component when you are deciding in. So if you see, if you are aware of today's freezing level over the radar station or close to the radar station, because we consider 200 kilometers around the GPS radius on to have similar upper air features. So if you're seeing the freezing level to be say at 4 kilometer, now if you're seeing in the radar cloud crossing 4 kilometer and 40 dBz reflectivity extending up to 6 to 7 kilometers, 3 kilometers above the radar, immediately you have knowledge that this is a cell in which there it has crossed freezing level. It has a high potential for squall or hail. This is what we observe, especially during the pre-monsoon season. The freezing level becomes the most important signature, not only to detect bright band but also the intensity of the thunderstorm. This is one thing. Second thing is, when we are seeing in the radiosonde data veering and backing of wind. Now radar also gives you, but that is an estimate. Radiosonde gives you actual. So if we are seeing over a station from morning, there is a veering of wind, there is a likelihood of winds traveling towards the station, in warm moisture coming in. Much before the cells start appearing in the radar, you have an idea that there will be a thunderstorm occurrence. So in these two ways, radio sound data and also the jet core. Sorry, third thing I forgot. The jet core location is a very important factor that comes up from the radio sound data. Vertical shear. So that gives you the vertical shear.
Okay, ma'am. Thank you.
Okay. Uh, Thank you, sir. Thank you all.
Now, before moving to the formal vote of thanks, I request Somesh sir to have few words about the lectures.
Okay, thank you very much, Dr. Avilas. Before I say my concluding words, I'd like to request Dr. Devendra Pradhan Sahab. He is the chairman of the lecture series on radar meteorology and also himself an expert on Doppler radar application. Pradhan Sahab, are you there? You can see his name logged in. Pradhan Sahab, are you there? Just logged in probably.
He was here, but not switch on his camera.
Are you hearing us, Pradhan Sahab? Please switch on your camera and say a few words. So, anyway, so thank you very much, Dr. Soma Roy, for a very interesting talk. Continuation of the last week's lecture on application of Doppler weather radar for nowcasting. Today also, a lot of interesting questions have been raised and very well answered by Dr. Soma Roy. It seems that most of the questions raised today from participants were regarding direct application for the weather forecasting. So some people appear to be aware of the weather forecasting issues, and some people are just asking innocently, only they're not aware of what the processes or procedures are there behind the weather forecasting. Say, for example, one of the interesting questions raised by one of the participants, and it was repeated also in many other talks earlier, about the cloud burst. whether radar can forecast the occurrence of the cloud burst, which is a very, very important thing. But as Madam has already told you, radar gives you the present state of the atmosphere, the present structure of the clouds, right? And at best, nowcasting based upon the previous images uh, observed by the radar. Okay, extrapolation of those images for nowcasting, etc. But actual prediction is done not only by radar, but based on many other things, including most importantly the NWP model, right? And somebody was asking about the income R, etc. So it seems that he's familiar, or at least he has heard about the income R, which is the National Center for Medium Range Forecasting Unified Model. And as it is a unified model, so obviously now it can be used for forecasting from local to regional to global scale. And in the income R, actually it is a regional model configured at 4 kilometer resolution, in which they also assimilate the radar data, all the radar data available in India from the IMD. They try to assimilate it and then give the forecast. So when it comes to forecasting, say for example, cloud burst, now, and you have asked the question, you should be knowing what the cloud burst is. Like by definition, it is an intense rainfall of about 100 millimeter per hour. Okay, per hour. Just notice it, per hour in a very small area of about 20 to 25 or 25 to 30 square kilometer. So there is a definite intensity of the rainfall to occur, and also over a very small area, not a very large scale area, like hundreds of kilometers. That becomes a different thing, not a cloud burst. So over that area, suppose when we say 25 square kilometer area, well, the radar has a good resolution, but the NWP model does not have, right? The one which, say, is run at income R, of course, I mean, sometimes people can configure the reservoir, etc. also at 1 kilometer resolution. So unless your model is configured at very high resolution, like 1 kilometer square, or at least 5 kilometer grid box, you will not be able to really determine whether the amount of rainfall that has occurred has really occurred over that small area of 25 square kilometer. Okay, so that is a very tricky thing, but then nevertheless, the combined DWR as well as NW products do provide the signature of the cloudburst event quite well. And many times the problem is that the cloudburst occurs, especially over the mountains in very remote areas generally, where there are no observatories, and the radars are also very limited. Like the radars are there, but then say for example, our entire Uttarakhand or Himachal Pradesh, there are only each state having about 3 DWR. Okay, 3 DWRs. But then cloudburst may not occur in the vicinity of those DWRs where the DWR is able to see it. Maybe it can occur over a place where it is completely blocked by the mountains. So there are limitations, the problems are there. And also once it occurs in the remote area, we don't even come to know whether it is cloud, just it is a cloud burst or just a large, exceptionally heavy rain. So like exceptionally heavy rainfall, without a cloud burst, then also it can cause flash floods. And when flash flood occurs, then people in the surrounding villages near the river, they get washed away. And then only people come to know that, okay, probably, very heavy rainfall has occurred somewhere, or maybe some cloud bursts occurred. So a lot of, challenging things are there for forecasting cloud bursts. Somebody was asking about the radiosonde, and Madam has very nicely explained, what is radiosonde? It just gives you a profile of the atmosphere, vertical profile of the atmosphere, right? Wind, temperature, humidity, etc., etc. So in olden days, we of course were dependent highly on the radiation profile, T5 gram. Based upon the T5 gram, people used to do the analysis of those, stability area, whether the layer of the atmosphere is stable or not, which are some of the very important factors for the occurrence of these convective weather, and many other convective parameters we used to get from the tiphogram. But tiphogram alone obviously cannot tell you everything about the occurrence of thunderstorm. So in current situation, everything is used together. Besides tiphogram, the Doppler radar, the satellite, the model, and everything together. But anyway, it's good that people have asked these questions, and I have seen a message from Tyagi Saab that Tyagi Saab is here. Given some message or no? No, he's not here. Maybe he has given message in WhatsApp. So it was nevertheless a very interesting talk again by Dr. Soma. And if you have not understood properly, you can always watch the YouTube. Once again, because all lectures are available on YouTube. By the way, next Saturday, there will not be any talk because it is, I think, some festival, Onam, right? Onam festival is there. So 14th, there is no talk. And again, we will continue on 21st of September by another speaker. So hope you will enjoy it again. And if you have any question, you can always write by email also. So thank you very much. And over to you, Dr. Avilas.
Okay, thank you, sir. So I invite Mr. Vijoy to propose the vote of thanks. Before that, I request all panelists to switch on their camera to have a photo session, a quick photo session. Swagata, are you here? Swagata is not here. Pradhan sir is also not here. It's okay, no problem. Okay, we are going to have a photo. Ready? 1, 2, 3. Okay, thank you. And I request Vijoy to propose the vote of thanks.
You're not audible. You're not audible.
Not audible. Muted.
Please unmute.
Good afternoon, all. As this is the 14th lecture of Sama, on behalf of organizing committee, I would like to extend my sincere gratitude to everyone involved in making this webinar a success. Firstly, a special thanks to Professor Someshwar Das Sir, Secretary Sama, for delivering such a thoughtful and inspiring presidential address. Your insights were invaluable and laid a strong foundation for the rest of the session. Our deepest appreciation goes to Dr. Soma Senroy for her excellent lecture. Your expertise and clarity made a significant impact, and we are grateful for your contribution. I would also like to acknowledge Mr. Sarakrishna S., engineer of ACARR CUSAT, for handling the Q&A session with such professionalism. As a big thank you to Dr. Abhilash S., director of ACARR CUSAT, and the program convener, our moderator, for managing the flow of today's event so smoothly. Your efforts ensured the session stayed focused and productive. To all our esteemed panelists, your collective expertise and contributions made this webinar truly meaningful. Lastly, I would like to extend my gratitude to our online participants. Your active involvement and interest made this webinar truly engaging. Once again, thank you all for your contributions. We look forward to your participation in future events. Thank you.
Thank you, Vijoy, for proposing the vote of thanks. And as Somesh sir was telling, next week we have Onam holidays. Like we are celebrating Onam, and advance Onam wishes to all participants. And we will be meeting on 21st again with a talk from Dr. Amar Jyoti on quality control and processing of DWR data for assimilation in NWP models. So till then, bye from CUSAT. Wish you all a very good day. Thank you very much for joining.
Thank you, Dr. Soma, for
Thank you.
giving the talk. Yeah, thank you.
Yes.